After almost an entire year, my rocket is ready for its first flight. Now I think before we fly the rocket, we should go through and highlight each part inside the rocket and see how it works. Inside the rocket, we have three main parts. We have the nose cone right here, which holds our parachute deployment system. We have the flight computer, which is right inside this little hatch. And then we have our thrust vectoring mount at the bottom. The thrust vector control mount is what holds the rocket engine. It gimbals the rocket engine using these two servos right here and here. I had to make cutouts inside of the airframe so that the servos could have a full range of motion. The thrust vector control mount can use either an E motor or an F motor, depending on if this blue piece is inserted. I'm going to be using the E motor instead of the F motor for the first few flights because it might be dangerous if I use the F motor. I've made a few videos about the thrust vector control system so far, and I'll put them in the cards and in the description. Moving on up the rocket, we have our flight computer inside. The flight computer is the brains of the operation. It has all the sensors that allow us to thrust vector control and to release our parachute, and also it runs all of our flight code to make sure to know what to do. I built the flight computer using a small prototyping board on top of an Arduino Uno. Together, they work together and run all the code very smoothly. In the future, I might upgrade to something more powerful, such as a Teensy or something else that I'll look for. The flight computer has been the most difficult part of this process. It took me many iterations to finally land on this final one that actually worked. I'm super excited about it, and I'm super excited to upgrade it and to keep making it better. As we move up the rocket from the flight computer, you find a little hatch hole right here, and that's used to connect the servo that deploys the parachutes to the flight computer, just so that I could get it through the small hole that it needs to get to the flight computer. And finally, up at the top, we have our parachute deployment system. This took way too long to make. It should have been super simple, but it wasn't. I started the process by designing this in a live stream a couple months ago. I decided that I would have the parachute come out of the side of the rocket instead of the top, because I thought it would be cool. And so, I decided to use a spring that would be released by a servo to push out like a door that brought the parachute with it, and then that would deploy the parachute. I don't know. It was a decent idea, but I tried so hard and I couldn't get it to work. This is what my prototyping looked like. I had a door here that was held on by some magnets, which are starting to fall off, and then some springs on the inside that were supposed to push everything out. But after, I spent a couple days just trying to get this to work and having a servo that would hold it in, but the issue was that it had to be, there's such a small area of margin that you have to be in for it to be able to hold for the servo to be able to hold this down without the springs being able to push it up. And yeah, it just wasn't working out. So I switched to this new design, which basically has a servo down here, which once we reach apogee, the servo will turn and it'll pull this top off. And then that top, if you can see, is connected to our bundle of parachute. And then when that is released, the parachute will come out and unwind and then deploy, and we'll land on the ground safely. Not smashing in at 90 miles an hour. Hopefully. But so that's the design. We've got two magnets here on the bottom that connect to each other, which just help hold it in place while it's flying up. And once it's in place, it's quite sturdy. And so yeah, that's the design I ended on. That was a lot of words, basically to say this was a pain to design, but I finally got it working. So that's how all the hardware of the rocket works. But I bet you're asking, what about the software? So the software took me a very long time to get right, but I think it'll work. Hopefully. Cross your fingers. The rocket's code is pretty simple to understand. We start out in our setup function. What we do in the setup function is we test all of our sensors. So we test the BMP and the MPU test. After we test both our MPU and our BMP, we set our servos to the correct offsets. Once we do that, we set our launch altitude. Our launch altitude is very important, so we need to make sure that we do that. We also set the servo at the top that controls the parachutes to hold in the parachute. That is everything that happens in our setup phase. After the setup phase, we move into the loop. The loop function holds three different functions. The first function that the loop function holds is idle on the pad, or pad idle. In pad idle, we're looking for liftoff, so we're waiting for the rocket's altitude to start to increase. So that's what the pad idle does. After we've launched, the pad idle state then moves into the powered flight state. In our powered flight state, we are thrust vectoring, and we are looking for apogee. Once we reach apogee, then we move into our unpowered flight state. Once we're in unpowered flight, then our parachutes are deployed, and we are looking for once we reach the ground. That's a large simplification of how the code actually works, but it should give you an idea of how the rocket works. It's currently L-3 for my first thrust-vectored rocket, Grapefruit 1.5. I'm super excited for the launch, and I'll put it up as soon as I can so you all can see it. Make sure you subscribe so that you don't miss it. With that, I wish you a Merry Christmas, and I'll see you later.